What we're going to do in this video is talk about acidity, and in particular we're going to talk about the pH scale. Now the first question is, what does pH stand for? And it turns out that there's some debate why we have this lowercase p here. We know why we have the H. And some people will tell you it stands for power of hydrogen, the capital H for hydrogen. Some people will say it's the potential of hydrogen. Some people will say it's the capacity for hydrogen. You might say capacity doesn't start with a P, but if you go into Latin, it can. But what do all of these things mean, and why do we care about hydrogen so much? Well, it turns out that hydrogen, and in particular a hydrogen positive ion, an ion is just a positively charged molecule, that a hydrogen ion can play a major role in how acidic or basic something is. And so the pH scale, you're going to see it go from 0 all the way to 14, with, of course, 7 in the middle. And something that is towards the left, something that is less than 7, is considered acidic. And so if you have a pH near 0, that is highly, highly, highly acidic, while something to the right is considered basic. And something in the middle is considered neutral. And another term for basic you'll sometimes see is alkaline. And alkaline actually comes from Arabic for alkali, which was the word that ancient Arab chemists used for a compound that happens to be very basic by our modern definition. But what does it mean to be acidic, and what does it mean to be basic? And once again, how does that connect with hydrogen ions? Well, it turns out, and I'm not going to go in depth in this video, is that things that are acidic tend to have lots of hydrogen ions, and while things that are basic tend to react with these hydrogen ions. There's other definitions for what it means to be an acid or a base, and we'll go into depth in chemistry class on that. But this is why it's connected with the term pH. Now, what are examples of things that are acidic? Well, you see it on this chart right over here. Here we're going in the vertical direction. Things in our everyday life that are quite acidic. A lot of fruits are quite acidic. For example, lemons and grapefruits and orange juice are quite acidic. They're at the low end of the scale. And some of the telltale signs for acidity is that if you were to drink it or eat it, that it would have this kind of sharp, sour taste to it. While if you go to the other end of the spectrum, things that are basic, these would be things like bleaches and ammonia solution, and we can even go super basic to liquid drain cleaner. And these are going to have more of a slimy texture to it. In fact, even soap is quite basic. And of the basic things that you could eat, you might have a bitter taste associated with it. But to be clear, I really don't recommend eating or drinking anything that is either highly basic or highly acidic. And the reason is that things that are at the extreme of the pH scale, so things that are either extremely basic or things that are extremely acidic, like battery acid or hydrochloric acid, because they're so reactive, they will damage you. If you pour it on your skin, it will damage you. If you ingest it, it will damage your cells, and it can even kill you. So don't try to taste things to see whether they're acid or basic. And if you do, try to make sure that they're closer to this middle range of our pH scale. So I've talked a lot about things that are acidic or basic, but also what's interesting is things that we consider to be neutral. So our blood, for example, is quite neutral. And this is something that doctors might measure, because if your pH in your blood gets a little bit too high or a little bit too low, that can cause some serious problems. Seawater is pretty close to being neutral. Milk is not that far off of being neutral. Now, with that said, in order to read the pH scale appropriately or to appreciate the differences in acidity and basicity, it's important to realize that it is not a linear scale. So for example, something that has a pH of 8 is not twice as basic as something that has a pH of 4. It turns out when you go from one level of our pH scale to the other, you are going up in basicity, say going from a pH 4 to a pH of 5, by a factor of 10. And so comparing something with a pH of 4 to a pH of 8, the thing with the pH of 4 would be 10, 100, 1,000, 10,000 times more acidic. Or you could say the thing with the pH of 8 is 10, 100, 1,000, 10,000 times more basic. So I'll leave you there. Keep a lookout when people talk about pH balanced or blood pH. And we're also, as we study more and more biology, we're going to talk about how pH might influence some biological reactions. And especially once you get into chemistry, pH will inform us what type of reaction is likely to happen.